we're going to figure out how to model functions as an equation, table, and even a graph. How would you match a table to a graph or equation? We want you to set up your spiral. Today is October 1st, 2012 for equations, tables, and graphs. Pause the video at any time if you need to. So far, you don't have to record notes, or if you can, you want to pause and write something down. An equation has an equal sign with it. A table normally is set up with the first column. A lot of times this is the x and this is the y. The graph correlates to the table. 112 would mean you go over 1, up 12. 224 is over 2, up 24. The table just really lists the coordinates that are on the graph, but if you plugged numbers into the equation, you could get the table. Now we're going to focus on making an equation. An equation helps you so that you can find future values. Since they already gave you the equation, this really stands for the height equals 12 per second. So if you were to make a table, what would that look like? On a table, you would tie it in, that you would make your first column can be your second column could be your height, and just make some predictions. If you only did this for 1 second, how high would the airplane be? 1 times 12 is 12. If you did it for 2 seconds, the height would be 24. If you did it for 3 seconds, the height would be 36. But interestingly enough, what's happening is this is going up by 12 per second. That's why this is 12 per s. 12 times the number of seconds. Now, write this equation into here. This is going to be the root equation of everything we're going to do. Y equals mx plus b. M is referred to as the common difference. Algebra students call this the slope. You can also refer to it as the rate of change. Many times you can also see it as y equals kx, although this is the common form. The b represents the zero position or the initial value. We will keep building on this knowledge as we goes on, but this is what would be the start value if your time was 0. What would be the y-intercept? Where does it go across the y-axis? The common difference is, if we're looking at a sequence, how do you get from one number to the next? What are you adding over and over again? So let's look at this equation. How do you get from 0 to 12? How do you get from 12 to 24? You're going up 12 every single second. Every second that happens, you go up by a height of 12 feet. That plus 12 goes in front of the s for the equation. Write that down in the spiral. Now if we look at this equation, how do you get from 3 to 4? How do you get from 4 to 5? How do you get from 5 to 6? Every single time we change a row, we change spots, we change the x, this is going up by a value of 1. This 1 is referred to as your common difference, or your slope. It's going up 1 per change in x. But now, if we have to find the 0 value, that means when x is 0, what is your y value equal to? Turns out your y value is equal to 3. Whenever the x is 0, the y is 3. Record that in your spiral. Let's look at this one. How much is this going up to get from this number to this number? This is going up by 3 when the t changes by 1 position, changes by 1. So if you're going to write this equation, you would actually write d, because that's the second letter. D equals, it's going up by 3 every time the t changes positions. But where is the start value? When the t is 0, what is the d actually equal to? That's a minus 1. That's going to go at the end of your equation. Sometimes they don't actually give you an equation, they give you a sequence. You can turn that into a table. The x is your position. The 2 happens to be in the first spot, the second spot, the third spot, and the fourth. You can look at it, the 2 is in the first position. The 6 is in the second position. The 10 is in the third position. The 14 is in the fourth position. So you would do 1 is 2, 2 is 6, 3 is 10, and 4 is equal to 14. Now, to write this equation, you would look at it. How much is this going up by every time the x changes places? It's going up by 4. But hey, we don't have the 0 spot. You have to figure out what is that number that comes before the sequence. What is if you followed it backwards? Instead of adding 4 every time, we'd have to subtract 4. That would bring it back. So we're adding 4 this way. So before this equation, we would subtract 4, which is 2 minus 4 is negative 2. So the equation is going to be y equals, you're going up by 4 every time you change your x position. What is the number that comes before? Negative 2. We're going to do that for this equation, and then this is going to be it for our notes for today. If 9 is in the first position, 7 is in the second position, 5 is in the third position, 3 is in the fourth position. Once again, how much is it going up per change in x? So you write the equation y equals, it's going up by 2. 2 is your common difference. 2 is the change in the numbers per change in x. But if I follow the sequence backwards, what would be the number at 0? What would be the start value? Come back, and the 11 would be the number before the sequence.